This is section 8.1 to 8.2, and today we're going to keep talking about sequences and series, and we're really going to bring back that notation from Algebra 2, which is this E-looking thing, which is really not an E, it's actually an S. It stands for summation, it's sigma notation. And we're going to talk about what all these pieces mean about it, and then how you can use it to kind of figure out an equation. So this one is summation notation, which means we are summing things together. The number on the bottom is the first thing you're going to plug in. So first number plugged in. The top is the last number plugged in. And this is the formula you're going to plug in too. So using that idea, we're going to try a couple here. The first one is I equals 1. 3i is our formula, and we're going to go until 5. So the first number I'm going to put in is a 1. So 3 times 1 is 3. Plus, this is summation, so we're adding these up. Next, I'm going to go to a 2. 2 plugged in is 6. 3 is 9. 4, 12. And 5, the last number, is 15. And then I'm going to add all that together, and I'm going to get 45. The next one, same concept. This one's starting at 3, though. So the first number I'm going to put in is a 3. I'm going to have 1 plus 3 squared, which is 10. And then I'm going to put in a 4. So 1 plus 4 squared, which is 17. 1 plus 5 squared, which is 26. And 1 plus 6 squared, that's my last one, is 37. Adding that all together, I'm going to get 90. One more. Here I'm going to infinity, which means I'm going to start by plugging in a 1. I'm going to get 3 over 10. Then I'm going to get 3 over 100, because I'm going to be 10 squared. And then 3 over 1,000, and this is just going to continue to get smaller. Well, the number is going to get bigger and bigger and bigger, but the fraction is going to get smaller and smaller and smaller. And we're supposed to do this up to infinity. I clearly can't go until infinity, so we do something kind of called a partial sum. And we're just going to see if there's a pattern that happens after the first few terms. So I'm going to do 3 divided by 10, and I get 0.3. I do 3 divided by 100, I get 0.03. And then I do 3 divided by 1,000, and I get 0.003. What I'm supposed to do is be adding these together. So if I take 0.3 and add it to 0.03 and add it to 0.003, I'm always going to get 0.33 for an answer. When we go to do the next one, all we're going to do is get another 3 tacked on. So our sum, if I keep adding this up forever, will just end up being 0.3 repeating. Because no matter how many extra terms I put out here, the bottom is just going to essentially gain one more decimal place, and I'm going to gain one more 3 down at the end of that decimal. Next, we're going to do it in reverse. I'm going to give you some numbers, some terms, and I'm going to ask you to write the sigma notation for them. So we'll start with the sigma. I would always start by writing the formula first before you decide what your numbers are going to be, what you're going to be plugging in. So look for things that are the same. I always have a 5 on top. On the bottom, I start with a 1, and then I'm going to add it to, and then this is the number that changes each time. So I have a 1, a 2, a 3, and then it goes all the way until 15. So 1 is staying still. This is what's changing. This is kind of like my n or my x, the thing that I'm plugging in. And the first number I plug in is a 1, so that's going to work. Next thing, when I plug in a 2, that'll work. I'll put a 2 there. And then a 3, so that pattern's going to work, and then I'm going to go up until 15. Next one, given my sigma here. Looking at my formula, looks like I always have a 1, so that's great. On the bottom, I'm kind of seeing, you know, this one's kind of tricking me. There's nothing under there, and then it goes 2, 4, 8, and then 124. And if you look real close, this one is positive, this one's negative, this one's positive, this one's negative. So every single time they're switching what sign they are. One way to handle a sign switch is to do a -1 to a power. And I'm just going to start off with n, and we'll see if this is going to work for us. So that -1, every time I plug in a power, it's going to switch from positive to negative. So the first time I plug in a 1, I'm going to get a negative. When I plug in a 2, it's going to turn it positive. I plug in a 3, I get a negative. So it's going to flip back and forth for me, which is what I need to have happen. On the bottom is a little bit trickier. So down here, I don't have anything. I mean, technically, I have a 1, so that's kind of helpful. These kind of look like you're multiplying by 2, which is the same as 2 to a power. So this is kind of like 2 to the first, and 2 to the second, and 2 to the third. And so if I back that up, this guy would just be 2 to the 0. So I think I could do an n to the 0, or I'm sorry, a 2. Now I need to write out. A 2 to the n is what I meant to say, because we're doing 2 to the exponent. So a 2 to the n. So when I plug in a 1, the first time I'm actually going to get a 2, which is not helpful. So I think instead of starting at 1, we're going to start at 0 instead. So 2 to the 0 is 1, and then negative 1 to the 0 is also 1. So I'm going to get that. That's going to work out. The first time I plug in a 1, I'm going to get 2 to the first, which is 2. And negative 1 to the first will be negative 1. So that'll take care of my negative 1/2. I just have to figure out how high I have to go to get to 128. So you're just figuring out what number needs to go in here to get you 128 on the bottom, and that's a 7. Okay, 1 left. Doing my sigma, I'm going to write a formula in front. On the top, that's kind of a different pattern, and I'll talk to you about what that pattern is in a minute. This one's kind of the same one we just did. We're timesing by 2 each time, so this is definitely a 2 to the n. And I'm going to have this start out with a 1. 2 to the first is 2. 2 squared is 4. 2 to the third. So that's going to work out. And there's only 6 of these. So in order for me to get to 64, I would just have to do 2 to the 6th. So now we got to figure out the top. This is a pattern of factorials. This is actually 1 factorial. This is 2 factorial. This is 3 factorial, 4, 5, and 6 factorial. So I'm going to do an n factorial up there. If you aren't used to those numbers, that's okay. You're just starting to learn about factorials. It would be the same as if I put maybe powers, like all the roots. I'm sorry, all the squared. So like 1, 4, 9, 16. So it's just another pattern to kind of recognize and see if you can notice that they're all the factorials. So doing summation notation, please don't forget that this is the first number you plug in. This is the last number you plug in, not necessarily how many terms there are. So like this guy had a 6 up there. There were not 6 terms. 6 is just the last number I go to plug in.